Hi, this is Math 1050, and this video is over chapter 4b, and we'll get into simple interest and then compounding interest. Alright, so simple interest is when the interest is applied to an initial principal or amount, and it's only applied to that initial principal or amount. Alright, and so simple interest applied onto the principal amount and only the principal amount. Let me write this correctly. Okay, so the principal amount is the initial payment, the initial investment, just initial amount you're basing the money on. We'll call it P. Okay, as opposed to a recurring payment where you pay every month, or you add it into an account every month. Okay, so when I say payment, it doesn't necessarily mean something you're paying on bill-wise, something that's being deducted from you. It means something you're putting onto either a loan or into an account, like a savings plan. The interest rate, this is the percentage applied to the principal. And we're going to call this R. Right, so R is interest rate, P is principal, the interest itself, we think of this as the total interest, is the absolute amount added to the account due to the rate. And we'll call this I. Okay, so this is your interest. And then your balance. This is the amount in the account after some time period, which time period is T. We'll have this in years. And the amount itself we'll call A. This is your balance. And so A is equal to your principal amount plus any interest added to it. Now the opposite of this is when you're compounding. Compounding is when interest accumulates on both the principal and the previous interest. All right. So for annual compounding, there's a specific formula. It's your principal times 1 plus your APR over N. N is your number of compoundings. raised to n times y being your years or your time. Right, we're going to look at symbols we use for the formulas. Normally we do this in Excel, but we're going to be doing this in Desmos, so it's going to be a little different. We won't have to go into detail about the symbols that we see in Excel, but I will write them in. For your balance, we use A for the amount. In Excel, it's FV. For your principal, we use P, and in Excel, it's PV. For payment, we'll use PMT. In Excel, you'll also see as PMT. Annual interest, APR. Same for Excel. Years, Y and Y. And then compounding, for annual compounding, N equals 1. And then total compounding is N times Y. And they use the symbol as N per. N times Y being just your N value, which is 1, times your number of years. So for annual, your total compounding is just your years. And then your rate is APR over N. That's the same thing. Okay, now for Desmos, we have calculators. These calculators are under, if you look on here, you have the start here, educational support. It's the first one before we get into our chapters. It's QR calculators. And just going to open up kind of a Word doc that has the different calculators. The ones we're concentrating on. The top one is just the Desmos. We'll concentrate on financial compounding. Then we'll get into what's called continuous compounding in this chapter. Savings plan formula, I think that would be in 4C. And installment loans. And then we may have to use the number of years for installment loans as at one point as well. So let me just open up the compounding. This is set up so the only thing you have to figure out is what these values are. The formula is already inserted, and so it would just pop our answer. So if we wanted investment of 120,000 at 3% interest rate every month, which is N equals 12, we'll get into that. Years 30, and we're going to end up with some future value. Let's set this to 1 for N, for annual. And then so let's say we have 2,000 that we invest at 3% interest rate for, let's just say, 10 years. We will end up gaining $687.83 in interest onto that 2,000. So we have in the account $2,687.83. All right, let's go now back to the notes. So we're going to look at both simple interest for some of these and then compounding interest. Simple interest is just a calculation that we do by hand. Compounding interest we use Desmos. All right, so while banks almost always pay compounding interest, bond issuers usually pay simple interest. Suppose you invest $1,000 in a savings bond that pays simple interest of 9% per year. How much total interest will you receive in 5 years? Okay, so again, the amount will be equal to the principal plus your interest. Okay. Your interest is your rate times your principal. Okay, so it's just R times P. All right, and so you'll have $1,000 plus your rate is 0.09, 9% times 1,000. So 0.09 times 1,000 plus 1,000, you're at $1,090. Right. This is in at the end of a year. Okay. Now with simple interest, it's just continually adding on your interest each year on these bonds, so you don't continue to apply the interest to the total, you just keep applying the interest to the $1,000 again. So in the second year we add another 90, and so we're at 1180, and that's 2 years. In 3 years we add another 90, and we're at 1270. That's after 3 years. 4 years we add another 90, so that's 1360. And in 5 years we add another 90, and that's 1450. And in 5 years we have a total of 1,450. Well, we ended up adding $450 in interest over that time. Right. So now let's look at how it would be paid in compounding interest. So the principal amount is 1,000. Interest is 9%. Doing it in 1 year, so N is 1. And we're going to do 5 years. And so we end up with this is compounding interest. The amount is going to be 1,538 and 62 cents. Okay. Compounding interest will add more interest on over time because the interest is being applied to a higher and higher number over time. Right, so 2 different amounts, 2 different methods of adding the interest. All depends on the type of investment you have. All right, so let's say your grandfather puts 150 under his mattress 50 years ago. If he had instead invested it in a bank paying 3% interest compounded yearly, how much would it be worth? Right, so the hardest thing with these compounding is figuring out what all the values are. So here we have P is 150. That's what your initial investment is. It's the only money you're adding into the account. R is 3%. The N is 1 because we're only looking at this annually. And then the years, we're looking at 50. So we're going to do this over 50 years. All right, so go back to this. 150, 3%. N is equal to 1. Years is 50. That 150 has now turned into 657.59 cents. Right. So it's, even 50 years, it's not drastic, but it's still more than the 150. Almost 150. Oh, I'm sorry, almost $507 more. All right, so that's compounding every year. You're adding the interest on each year as we go through. We also have other time payments where the interest is added semi-annually, so every 6 months, quarterly, every 3 months, monthly, every month, or daily, every day, right? And for each of these, it has a different value. So for semi-annually, n equals 2, quarterly, n equals 4, think of 4 quarters in a dollar, monthly, n equals 12 months in a year, daily, n equals 365. We don't take into account leap year. All right. Everything else stays the same with this formula. Your P is still your principal, your APR is still your rate, N is still your number of compoundings that changes. Y is your number of years. All right. All right, so let's say we want to deposit $4,000 in a bank account that pays an APR of 3% and compounds interest monthly. So principal amount is $4,000. APR is 3%, so 0.03. Compounds interest monthly, so n equals 12. And the years is 4 years. Now, we have to find our rate. It's not just the APR, not like it was in these previous problems where your interest given was just your interest. Your rate is your APR over however many times it compounds. So in this case, it's be the 3% over 12. And so it'll be 0.0025. All right, so we can do this again on Desmos. So principal amount, 4,000. Rate. Now, one thing with this is in this formula, this rate is your APR. So we will put in 0.03. Notice it is dividing it by n. And then n is 12. And so you change your years to 4. Okay, and so you end up with an amount that's $4,509.31. Okay, I'm showing you this because this is the rate per month, but that is not what you include into the Desmos calculator. You will input in your APR because, again, the APR per month is what's part of your formula here. All right. Now, with this, we also have what's called an annual percentage yield, and you can do this no matter what kind of compounding you have when it comes to your n value, whether n is equal to 1 or n is equal to 12. We also call this the effective yield. Switch colors. And what this is looking at is the percentage by which the balance changes in 1 year. Think of this as the average change. And your APY, your annual percentage yield, is the amount minus the principal divided by the principal. But there's one thing to remember with this. is we can actually separate this out. Amount divided by the principal minus the principal over the principal, which is the amount divided by the principal minus 1. And then if we remember with this amount, that is the principal over 1 plus your APR over n to the ny. And so this is actually, the principal can divide out. And so you find out that it really doesn't matter what you invest. An account can have a specific yield percentage-wise no matter what you invest. And so you end up with 1 plus APR over n, then ny, minus 1. This p cancels with that principal. All right. So you deposit $800 in a bank account that pays an APR of 9%. Find the annual percentage yield with monthly compounding and with daily compounding. All right, so with monthly compounding, n equals 12. With daily compounding, n equals 365. We'll do this in 2 different times. And again, we don't have to go as far as finding the actual amount, because the principal itself does not matter. We can use the last formula we have, 1 plus your APR, which is 0.09 over 12 times 12. And we're doing this annually, so the years is always going to be 1. So 1 plus 0.09 divided by 12. This is 1.00075. And we're raising this to the 12th power. And we get 1.094. Right. That was only this part of it. Still got to subtract 1. Alright, so that's that. And then 1.094 minus 1, 0.094. So your APY is 9.4% interest. Or 9.4%. Do the same thing with our daily compounding. And we're raising this 365 times 1. So this becomes 1.0002 raised to 365. And again, we're subtracting 1 here. You get 1.094 minus 1, which is going to be 0.094, which is again 9.4%. So in this case, there's not much of a difference between monthly compounding and daily compounding. You still have an annual percentage yield about the same amount. Right. Continuous compounding has a different formula. This is when the interest is applied every moment to both the principal and the previous interest. Is actually the most the highest value you're going to get, and it's kind of the limit of what you can make onto an account. This formula is A equals P E to the APR times Y. Everything is the same. This E though is something you haven't seen. This is your exponential. This E technically equals 2.71, but it's not exact numbers like pi. It keeps on going. You can find this on a calculator. It's just second natural log, and you can get this on Desmos. If we put in, I'm just gonna put in E in this, you get the value itself. So Desmos recognizes it as just E. All right, we have a calculator for this as well. This is the financial compounding continuous. So it has the formula already in here. E is already in there. All you have to do is add the principal, add the rate, add the years. You actually don't need the compounding. It's just there because it's there. It's going to add in everything. So you deposit $1,000 in a bank account. So P is your 1,000. APR of 8%, 0.08, and you're doing continuous compounding in 10 years, so years is 10. We'll plug these values in. So 1,000, 8%, 10 years, and our amount is going to be 2,225.54. Yeah. So that's continuous compounding. Now notice I haven't used any of the equations itself. That's because we have the Desmos calculators. We might as well use them. We can always open up Desmos and type them in. You can always find and Google these calculators. You will have them available on the test. But if you need to or you want to go back and try some of these using these formulas, it's a good way to kind of verify that you know how to put them in the calculator. If you want to do it that way. The three formulas though you'll want to remember at this point then is A equals P, the 1 plus APR over N to NY. And here, annually is N equals 1. N equals 2 is semi-annually. N equals 4 is quarterly. N equals 12 is monthly. N equals 365 is daily. Those are the common ones. Then the other thing is when you plug it into the calculator, you may want to put parentheses around the NY as your exponent. That way it makes sure that if you type it in, say it's N equals 12 and Y equals 2, you can either do it to the 24th power or you do it to 2 times 12, but you gotta make sure that your parentheses are on the 2 times 12. Right, the other one is your APY. Here your principal cancels out and you end up with just 1 plus APR over N to the N, and it's always N times 1. And then minus 1. And then your amount with continuous compounding is A equals P E to the APR times Y. That's continuous. Now, last thing I want to mention, percentage yield. We can find that also with the continuous compounding. Okay, again, let's do this problem up here. We have our APY is A minus P over P. which becomes A over P minus 1. With continuous compounding, it's B P e to the APR times the years over P minus 1. And then the principal amounts cancel. Your Y is actually equal to 1. So with continuous APY, it's just your E, the APR times 1. So we won't write that in. E to the APR minus 1. Okay, so that's continuous, continuous. So these are the formulas you want to kind of remember or to work with if you're doing it straight from the formulas. The APYs are the two formulas you have to calculate by hand. And then the last one that we saw at the beginning, your simple interest. Is again your amount equaling the principal plus the interest, which is just the principal times the rate. Alright, so those are the formulas. And again, that one's also by hand. Alright, in the next video, we'll look at savings plan formula. It has a longer equation and it uses a payment. Again, we're going to be doing this on Desmos, so we just use a calculator for it. All right, I'll see you then. Bye.